We're now going to do some problems that involve and use the dot product. So let's do a couple quick sort of definitions or formulas. So dot products involve having two vectors. So let's say vector v is, we write this in, we'll call it a1, b1, j, and vector w would be a2, I plus b2, j. So we have two vectors in ij form. So the idea is, if you have two vectors, here's vector v, and here's vector w, and then you have the angle between the vectors. The key equation is this. Here's an equation that we can use to find the angle between two vectors. So this numerator, even though it looks like the multiplication, but because these are two vectors, this is called the dot product. And then in the bottom, we have the magnitudes of the two vectors multiplied by each other. So this gives us a way to find the angle between two vectors. This dot product we need to define. You take the I parts and you multiply them of the two vectors, and you add to that the product of the j parts of the two vectors. The dot product is not a vector, it's just a number. So the typical problem is they'll give you two vectors and they'll ask you what's the angle between the two vectors. Now there are some special cases. Sometimes you have two vectors that are parallel, and there's actually two kinds of parallel. So here's your vector v, and then it turns out your vector w is right on top of it. So obviously that angle would be 0. But you could have vector v and vector w here. Now these are parallel, but the actual angle would be 180 degrees. And then the last special case, it's like a right triangle, so it's not a right triangle, but a right angle, 90 degrees. And there's another word, 90-degree angles are called orthogonal. You'll see that word. And then, of course, the last case, well, it's like this one. Here's the angle. It's not a special angle. So for this one, the angle would be 0 degrees. I mean, these would be called parallel. Here the angle is 180, but the two vectors are also parallel. Here, 90-degree angle orthogonal. And then up here, a lot of times, sometimes I'll ask a question. Here are two vectors. Are they parallel, orthogonal, or neither? So if it's just some random angle, it's sort of classified as neither. All right, let's just do some problems, and you'll see some of these probably special cases and some of the problems we do. So the first one, here's how the problems typically go. They have you do these problems in steps. So here is vector v, 4i plus 5j, and here's vector w, 5i minus 4j. Now here's a big strong suggestion. Like a lot of these problems with the vectors, as a sanity check, as I'm doing the problem to make sure I can catch any mistakes I make, I'm going to do a rough sketch of these two vectors. So 4i plus 5j, 1, 2, 3, 4. So this is the I, the x-axis, 1, 2, 3, 4, 5. So 4i plus 5j, there's vector v. Now vector w is 5i, and then minus 4j. Now from the looks of it, this could be a 90-degree angle, but you don't know for sure until you actually do the math. So normally they give you vectors, and the first thing they ask for in the problems they're going to do is they ask for the dot product. So once again, the easy way to think about the dot product is you take the two, what I call the I values, and you multiply them. Right? 4 times 5. And then you add to it, you multiply the two j values. 5 times negative 4. 20, this is negative 20. Looks like the dot product is 0. Now the next question they ask you is, what is the angle between the two vectors? So what we do is, we take this equation, where it's the dot product over the product of the magnitudes of the two vectors. We just calculate the dot product to be 0. Now here's what's interesting. I could, just for fun, calculate the magnitudes of the two vectors and plug them in, but you know what? If I've got a 0 in my numerator, I know the answer has to be 0. So now you think, what's the angle? Give me an angle where the cosine is 0. Well, I don't have the unit circle with me, but if you think about it, where's the cosine 0? Well, either up here at 90 degrees or down here at possibly 270 degrees, but we're going to say 90 degrees. So you can see we've confirmed this was in fact a right triangle. And then the last question asked, so it's a multiple choice. Are those two vectors neither parallel or orthogonal? That's the first choice. Second choice, are they parallel? Third choice, are they orthogonal? Obviously, since it's 90 degrees, you would say they're orthogonal. So it's interesting how once the dot product is 0, you don't even really need to do this calculation. You just know the cosine of theta is 0, and you know you have a 90-degree angle. Let's do a couple more. For this problem, vector v is square root of 3i plus j, and vector w is I minus j. Same questions. They first want to know the dot product. So square root of 3 times 1, so the I parts, plus 1 times negative 1 So it looks like this dot product is square root of negative 3 minus 1. Let's just leave it like that for now. I think eventually we're going to use our calculator, but for now we'll leave it like this. So now they want to know the angle between these two vectors. And once again, just as a sanity check, square root of 3, I have my calculator, square root of 3 is like 1.7. So if you can imagine, so this is like 1.7 and 1. So 1, 2, 1.7 and 1. So maybe this is vector V. W is 1 minus 1. So there's vector W. Now, who knows? Could be like a 90-degree angle. Don't know. Have to do the math. Although actually, think about the last problem. For it to be a 90-degree angle, the dot product has to be 0. It's not 0, so it's actually not going to be 90 degrees. Well, let's see what the angle is. So you take your dot product. So once again, I'm not going to rewrite this every time. You take your dot product and over the magnitudes. So the dot product is square root of 3 minus 1. Now magnitude of V, remember magnitude is you take the square root and if you square root of 3, it's going to be 3, and then you square 1, it's going to be 1. Now the magnitude of W, you square 1, which is 1, you square negative 1, which is 1. So it looks like we have, this is square root of 4, square root of 2. So if I want to get the angle, what I have to do is so this we could try to simplify it, see if it's a special angle, but let's just go ahead and grab our calculator. Now I'm going to take the inverse cosine, and I want the answer in degrees, so I make sure my calculator is in the degree mode. Now this is sort of a messy, on my calculator, here's how I'm going to do it. I'm going to take square root of 3 minus 1. I'm going to divide it by 2 and also divide it by square root of 2. So it looks like this number here is like 0.2588. Now I'll just go ahead and hit inverse cosine on my calculator. And it looks like, turns out, it's actually not a special angle because 75 degrees is not a special angle. Special angles are 30, 45, and 60. It's a nice number, nice round number, but it's actually not a special angle. So the first answer to the question, here's the dot product. Here's the angle. And then you would say it's neither parallel nor orthogonal. All right, let's just do two more. All right, actually, two more like this, then one more with a little twist to it. All right, so V is 3I plus 4J. Vector W is negative 18I minus 24J. This is sort of a little bit of a pain to graph because these are pretty big numbers. So maybe we'll go like 5, 10, 15, 20, 25. -5, -10, -15, -20. So 5 and 5. Because this one's 3i plus 4j, so 3, it's about right here. So there's vector v. And -18i is maybe right here. -18 and -24 is, here's a good guesstimate. Now, I don't know for sure, but a possibility is that these are parallel, of course, opposite directions, so maybe the angle might be 180 degrees. From the rough sketch, that's a possibility, but to know for sure, we have to do the math. So the dot product, multiply the I parts, 3 times -18, and you add, multiply the j parts. These are actually pretty big numbers. -54, this is 80 plus 16, I think -96. So actually -150. Wow. So now we want to know the angle. We're going to say the cosine. So the dot product is in the top. Magnitude. 3 squared is 9. So magnitude of v, 3 squared is 9, plus 4 squared is 16. Magnitude of w, and of course it's a square root of all that, -18 squared plus -24 squared. So let's just figure out what this is. So -18 squared, so this is 324, and -24 squared is 576. So when you add those together, you get 900. So really, this is square root of 25. So square root of 25 times square root of 900. Square root of 900 is 30. So really you have 5 times 30. So it looks like you have -150 over 150. Looks like the cosine is -1. So now you ask yourself, you can just do this in your head, what's the angle where the cosine is -1? Well, the cosine is -1 is over here. What's that angle? 180 degrees, right? So the angle is 180 degrees, and therefore, what we said is true, what we thought might be true. Those two vectors are parallel. Let me do this last one of this kind. It's very simple, but might throw some people off. Vector v is -4j. Vector w is I. Normally with vectors we're used to having an I part and a j part. In this case, what this is saying is for vector v, I is 0, the I part, and for vector w, the j part is 0. So if we were to graph this, -4j would just be like this, and I is right here, so this is, so I'm pretty sure these are going to be, I mean actually at this point I know it's going to be orthogonal 90 degrees. Let's just confirm it. If we do the dot product, So the I part of V is 0 times 1, and then -4, and the J part of W is 0. So you can obviously see the dot product is 0, which means the angle is 90 degrees, which means they're orthogonal. Now there's one more problem with a little twist. What they do is they give you the two vectors again. Vector V is I minus, now instead of giving you a number here, they leave it as the variable A. And then vector W is 9I minus 7J. And they want to know what should A equal for V and W to be orthogonal, which really means the angle between the two vectors will be 90 degrees. Well, if you remember, for orthogonal vectors, or for the angle to be 90 degrees, the dot product has to be 0. So let's calculate the dot product and say equal to 0. So the I part's 1 times 9 plus -A times -7. There's the dot product. It has to equal 0. So this is 9 plus 7A equals 0. If I solve for A, if I subtract 9 from both sides and divide by 7, for those two vectors to be orthogonal, A would need to be -9/7. So that's the dot product.